Oh, that was funny. I'm so glad you're here. That was funny. Oh, funny. Okay, hey, we learned how to add the last day we're in this class. We got common denominators by multiplying by 1 over 1. All right. I'm going to have this equation. These are rational numbers. They can be made as fractions. And because they have fractions, some people think that this is going to be difficult. All right. You've done equations. You've done a lot of equations in your career, in my class, and in other classes. You know, you see these fractions, and that might make some of you distressed. It might make some of you distressed a little bit, but it doesn't happen to, because I don't like fractions. In fact, we were at an Eastridge game against Eastridge, and I couldn't believe it because we never get along with Eastridge. And our fans started chanting, "We don't like fractions, no we don't. We don't like fractions, how about you?" And then they go, "We don't like fractions, no we don't. We don't like fractions, how?" And then we go, "We don't like fractions, yes we don't. We don't like fractions, how about you?" Then one of the Eastridge kids said, "What's a fraction?" Okay, all right. But we sort of agreed we didn't like fractions. So in fact, I will agree with you. By the way, there is a 1 under here. There is a 1 under there. If we were looking at common denominators, so now I'm looking at later in elementary school or middle school, if I were to look common denominators with 5, 7, and 1, what is that common denominator? 30, more of you? 35 would be your common denominator. So what I'm going to do is I'm going to multiply this one by 35 over 1. Oh no. Oh no. Are the mathematical police about to come and arrest me? Have I done something mathematically illegal to multiply that by 35 and say they're still equal? Is that wrong? Yes. That's wrong. Here come the mathematical police. Hey, I'm going to multiply this one by 35 over 1. Are the mathematical police on their way? Yeah. Are they still equal? But now, I'm going to multiply this one by 35 over 1. Hey, I'm not allowed by law to give you money, okay? But if Lily and George had the same amount of money, your amount of money was equal to your amount of money. If I were to give you $5, sorry, I can't. If I were to give you $5, and I would give Giorgio $5, would they both have more? Would they still be equal to each other? They'd have more, but they'd still be equal. Or if I cut your money in half, I am allowed to do that, and I cut your money in half, they'd have less, but would they still be equal? Yeah. So here, when I multiply everything by 35, they're bigger, but still they're equal. Say, that makes sense. Now, did we just do a little cheer about not liking fractions? Yeah. Yes. Okay, so let's destroy the fraction. I'm going to do one other thing here. This always works. Does 5 go into 35? Yes. It goes in 7 times, cross it out, make it a 7, and then immediately go below it and write 7x to try to get it away from all the messiness. Does 7 go into 35? Yes. It does. How many times? 5 times. Right away, let's get away of the messiness. 6 times 5 times x is 30x. I might need somebody with a calculator to help me out. 9 times 35, 315. Some of you like math, some of you don't like math, some of you don't care, some of you are in the middle. However, one thing you have to admit, every once in a while, it goes from difficult looking. Every single one of you has passed Algebra 1. All of a sudden, none of you are stressed out. You might have been stressed at the start. You're not stressed out now. We have 37x is 315. Divide both sides by 37. And x is 315 over 37. Let's just leave it as a fraction. Because as we have the worksheets handed out in about 15 minutes, Don't know who I'm gonna choose. Don't know who that'll be.
Yes, you know who.
Don't know who that'll be.
I know who it is.
I don't want to start a fight. All right. If you'd please, and you probably will, because you're nice, compliant people. Compliant means you do what you're asked to do, which is pretty cool. And we've got 7, 8. All right, you've done a large number of equations in your mathematical career. What is the common denominator of 3's and 2's? The common denominator of 3's and 2's is? It's 6. If I multiply this side by 6 over 1, and this side by 6 over 1, they've got a different value, but is the equal sign still intact? That's the key. The equal sign is still intact. Both sides multiplied by the same thing. This is cool because it always works if you use a common denominator. Does 3 go into 6? Goes in 2 times. And right away, well, you think about it, write it down to get away from sort of the mess. Does 2 go into 6? 3 times. Right away, we can go 3 times 7, it could go 21. And I was shocked yesterday. See, usually you're the first class I teach things to, the first Algebra 2 class. And then I know how things go. But now I've taught 5th and 6th hour, and I was really surprised at how much people were forgetting the distributive property. Everybody in the room gets multiplied by 2. Everybody in the room gets multiplied by 2. So what happens is everybody in the room, everybody in the room gets multiplied by 2. Not in the room, not multiplied by 2. 2 times x, 2 times 7, and I believe anyone who might have been stressed out at the start of the problem is very much not stressed out anymore. Take away 14 from both sides, of course. Divide by 2. You could say 3.5 if you want. Nice, 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 nice. I think people at home think it's so fun when the recording moves. Here, this might be fun. Oh, that was like a 360 view. I had to show the ceiling though, because I can't video you. We don't know who you are. Hint, leave a little room, hint. If you possibly have any confusion, feel free to put a denominator of 1 there. If you think you might have any confusion, feel free to put a denominator of 1 there. All right. The common denominator with 4 and 5 would be 20. How many of you say, here, real quick, out loud, start counting from 15 to 25, out loud. Do it, 15, 16. Listen to yourself, 18, 19, 21, 22. How many of you? How many say the top one? I do. 19, 20, 21, 20. How many of you say the bottom one? 20, 21, 22, 23, 24, 25, 26, 27. Okay. How many are lazy? I'm lazy. Just 20, 21, 22. All right. Hey, 20 is the common denominator. I can't just do that. I can't just do that. If I've done it everywhere, I can do that. Ah, they're bigger, but the equal sign remains intact. 4 goes into 25 times right away. Get rid of the mess. Anytime you've got a bunch, all numerators and denominators are in parentheses. We just sometimes don't do it. I mean, we don't need to write them. We certainly do here. 6 times 20 is minus 120. On the other side, it always works. 5 goes into 24 times. Write it down right away. Yep. Oh, and this is a perfect example. Perfect example. Use a temporary pass. Mine is that messy. Everybody in the room gets multiplied by 5. Everybody in the room gets multiplied by 5. So look, so what happens is everybody in the room gets multiplied by 5. Look, Jake doesn't get multiplied by 5 because Jake's out of the room. Ooh. We'll have to tell him when he's back. He didn't, because he's not in the room. Only the people in the room got multiplied by 5. 5 times x. 5 times 3. 4 times 5, 20. 4 times 8. Just clean it up a little bit. I'm going to take away 5x on both sides. Because this is algebra 2, I can do this. I'm also going to combine these two at the same time. So I'm taking away 5x on both sides. I'm putting these two together. And there gets to that point where nobody is stressed out. At 8, I mean, we're all good with this now. Your answer is, keep it like this. Cool. I bet I have to stop this recording.